Okay, next hint video. So these are your numbers that you put in, 0, 2, 3, 5, 8. Maybe that's what you got, maybe it's not. And then I'm going to go to my next slide, the growth factor as a percent change. It's going to be a little confusing. So I've written in there that you want to find the percent change as much as it changed every time. You want to find it as a percent, okay, because this is a growth factor, so we're going to look for a percent. What you do is you do the new minus the old divided by the old. So the new number minus the old number divided by the old number will give you the percent change, right? So like anytime you have a percent, you're finding the difference between the new things and dividing it by what you had as a percent change. So take a look at these. You'll see that, like for instance, number the first one doesn't, you can't really do, it's not applicable because we had 0 to start with and we can't have 0 on the bottom. So we're not going to do that one. But the next one, we went from 2 to 3. So I do 3 minus 2 over 2, which is 0.5. Okay, so all of these numbers I'm calculating by hand. Okay, so all of these numbers you're calculating by hand. 5 minus 3 over 3 is 0.666. Then it says to find the average rate in your experiment. So my average rate, I'm actually going to do, add up all those averages, 0.5, 0.666, 0.6, 0.625. Probably fine if you just go to the nearest thousandth. I went a little further on this one, but go to the nearest thousandth if you can. And I get the answer 0.5979. That's my average percent growth for the entire thing. So I'm going to take that average growth, and that's what I'm going to use to make my exponential function. So go to my next slide, and it shows you what an exponential growth function is. Take a minute, write that down in your notebook, okay? That's an exponential growth function. So it's very similar to the one we showed you yesterday, only the growth factor is 1 plus the rate, okay, in decimal form, in percentage, which is what we have. I actually said percentage here, but it's really a decimal, right? Percentage would be 59%, 59.79%, but it's 0.5979. So in the rate is in a decimal form. The final amount is the y, or that's going to be our function. The initial amount, a. So in our case, what's the a? What's the r? How many M&Ms did we start with? Well, we actually started with 2. This was our initial one. I had 0, 0, but our initial was really 2. We started with 2 when we started graphing. So your initial amount is 2. Your a is 2. What's my r? Yours will be different than mine. I found mine right here. 0.5979, and it's 1 plus that for the entire growth factor. So, and then the t is for over time. What happens? Okay, so we had talked about that being an x at the top, raised to the x. You're talking about exponential growth. It's growth over time, so you generally put it over t, although in Desmos, you know, we have to use x. So here's my function. I put it in. I saw what the graph looks like. What's it look like? Exponential function. It's growing exponentially. So my M&Ms, even though I only did it with 5 trials, and you will do it with a whole lot more trials, right? I only did 5 trials here. You're going to do hopefully 15, 16, 17 trials and get your good average in there. The next question is, use that function to predict the 25th, the 50th, and the 100th trial. So how do I do that, right? So this is I can see when it's up to the second trial, but what about when I zoom out? Can I see up to 25? How do I do that in Desmos, right? How do I find what it's going to be at 25, 50, and 100? Can we do that? What do I think that number is going to be? You might be surprised what it's going to be if you were to get up to 100. That's it for now.